Good afternoon. Good afternoon, everyone. Today we will start a lecture on steel structure. So already in previous lectures, we have find out how to find out the tensile strength of bolts. Okay. So in last lectures, we have seen the connections, that is the welded connections and bolted connections, and also we have solved one problem related with the bolted connections. Okay. So again in today's lectures we will solve the problems related with the bolted connections. So in bolted connections, in short, I will go through the things which we have already discussed in last lecture. So in bolted connections, first we have to find out the strength of bolt. How to find out the strength of bolts? So in order to find out the strength of bolt, first we have to find out the tensile strength of bolt. That is tensile strength of bolt, it depends upon two things. Okay. So first we have to find out the shear strength of bolt, and then we have to find out the bearings of bolt. Okay. So here I am having the IS code, that is 800 2007. In order to find out the shear strength of bolt here, in order to find out the design strength of bolt or shear strength of design strength of bolt, first we have to find out this V, that is suffix dB. So it is VDB is nothing but the design strength of bolt taken as the smaller of the values as governed by the shear, that is VDSB. And we have to find out the bearings also, that is VDPB. That means these two things we have to calculate, that is shear and bearing, in order to find out the tensile strength of bolt, in order to find out the design tensile strength of bolt, or in order to find out the design strength of bolt, first we have to find out the VDSB, and then we have to find out the VDPB. This is all given, this all things, it has been mentioned or it has been given in IS code, that is 800 2007. That is page number 75. From page number 75, first we have to first we have to find out these two things, and the smaller value, the shear and bearing, will be the bolt value. Okay. So in page number 75, that is clause number 10.3.3. So this in clause clause number this, that is first we have to find out the shear strength of bolt, that is the shear capacity of bolt, and then we have to find out the bearing capacity of bolt. Okay. So these things already we have discussed, or already we have taken in the previous lectures. Okay. So first, in which things, shear capacity of bolt, how to find out the shear capacity of bolt? So with the help of this formula, we can find out the shear capacity of bolt, that is VDSB, that is equals to capital V NSB divided by gamma MB. How to find out gamma MB? Again, it has been given in table number 5. Okay. So in table number 5, we have to find out the value of gamma MB. That is gamma MB, it is nothing but it has been given as the gamma MB. The values, it is taken as 1.25 and 1.5. Okay. As per it has been mentioned in the table. So we have to refer this table while finding out this gamma MB. How to find out V, that is NSB? So VNSB, again there is a formula for this, FU divided by square root of 3, again in bracket. Okay. NN ANB plus NS ASB. What is this NN? That is number of shear planes with threaded. That means how much threaded portions are there. So we have to take this NN from the threaded portions. Okay. Again, what is A and B? A and B, the area of the threaded portion, plus what is NS? NS is nothing but the shear planes without thread. NS is nothing but the planes without threads. Again, what is this ASB? The area of that bolt where there is no threads. Okay, so ASB is the area of the bolt where there is no threads are taken care. Okay. So again, with the help of this formula, we will first find out the shear strength, shear capacity of bolts. Then we have to find out the bearing capacity of bolt. So here I am reading this problem. Here, calculate the strength of bolt. Yes, calculate the strength of M16 of grade 4.6 for a double cover butt joint. So here there is a double cover. Already in previous lectures we have seen the single cover butt joint also. Here there is a double cover butt joint. What is butt joint? What is butt joint? Butt joint is nothing but the joint which has been taken care. I will draw this butt joint. Yes. So butt joint is nothing but first we have to find out. Yes. So butt joint here, the figure for this butt joint is nothing but in this way. So there is a figure in this case. Okay, these are the two plates. One plate is here. The second plate is this plate. These two plates are jointed with the help of the butt joint. Okay, one plate is this, second plate is this, and it has been joined with the help of the two cover plates. That means there is a cover plate at this top end, and there is a cover plate at this, again there is a cover plate at this bottom. That means this two plate, it has been jointed by the two cover plates. Okay, this joint is nothing but the butt joint. When the two plates it has been connected, these are the two plates, it has been connected by the two cover plates. So calculate the strength of M16 of grade 4.6 for a double cover butt joint. Again, the main plate to be jointed are 12 mm. That means these two plates are 12 mm. That means this plate is of 12 mm. These two plates are of 12 mm. And cover plate, it is nothing but for 10 mm. That means this cover plate, it is nothing but it has been taken for 12 mm. Okay, this is nothing but the cover plate at top and bottom, it has been taken as 10 mm. What is the use of this M16? What is the use of this M16? The M16 is nothing but this 16 represents the nominal diameter of the bolt. Okay, so 16 represents the nominal diameter of bolt. So M16, the M is nothing but the grade of bolt, and 16 stands for the diameter of bolt. So this 16 stands for the diameter of bolt. Okay. What about this 4.6? What is the use of this 4.6? So 4.6, it has been used as the yield stress of the bolt. The yield stress of bolt, again it has been mentioned in IS 800 2007. So again we have to that is 4.6. We have to take the value of 4.6 from the table which has been mentioned in IS, that is 800 2007. The main plate to be the main plates are of these two plates are of 12 mm. The cover plate, it is for 10 mm. Next, what is the thing? The M16. So 16 is the diameter of the bolt. So here I have written as d, small d is equals to 16 mm. What about the diameter of bolt? So here we have to take the diameter of here the diameter of bolt is 16 mm. Or the diameter of hole, it has been taken as extra as the safety as 2. Okay, so 2 plus du. From where we have taken this 2? Again this 2, it has been taken from IS 800 2007. So we have to take this 2 from IS 800 2007 to factor of safety for that is the holes. So diameter of hole is equals to 2 plus du. Du is it is nothing but the diameter of bolt. So 2 plus 16, it comes to be 18 mm. What is grade of steel? Grade of bolt, here it has been taken as 4.6. So we have to take this grade as 4.6. So 4.6, it has been taken as here. Again, from depending upon this 4.6, we have to refer the table that is being mentioned in IS 800 2007. So FUB, that is the yield stress, the maximum tensile yield stress is FUB is equals to 400 for 4.6 grade Newton per mm square. FYB, it has been taken as 240 Newton per mm square, and FU, it has been taken as 410. Again, these things, it has been given in IS, that is of 800 2007. So again, it has been taken from IS. So we will see from which year. Here it has been taken from this IS, that is the yield stress. Okay, I'm showing the yield stress from where it has been taken. So it has been taken from this IS yield stress and the maximum yield stress. Okay. Yes, so it has been taken from this. This is nothing but the impact factors. Sorry. So yield stress to be taken from the IS codes, which has been mentioned or which has been given in the IS codes. So we have to refer the IS code properly in order to take the yield stress also. Okay, these values FUB, it has been taken as 400, FYB, it has been taken as 240, and FU, it has been taken as 410 from the that is being given in IS codes, that is being given in the table for 800 2007. Again, first we have to find out the area of the, that is nothing but the shank portion. Okay, so here if we are drawing this bolt, so this bolt, and these are the threads in the bolts. Okay, so these are the threads in the bolts, but here this is nothing but the shank area, and this is nothing but the threaded area. If we are drawing this as this is nothing but a small figure for bolt, in which this is the top head of bolt, here this is shank area, and this is nothing but the threaded area. Okay, So here we have to first find out the shank area and threaded area. Shank area is nothing but the plane area. That means the area will be total. So ASB is nothing but the area of shank area. That is ASB pi by 4. That is diameter of bolt d square. So d square, the diameter of bolt is 16 square. So pi by 4, 16 square. It comes to be 201 for the shank area. That is top area. What about the threaded area? That means the area in this threaded portion is somewhat less as compared to this. So how much it is less? So here we will take as 78%. So 78% is nothing but 78 divided by 100. It comes to be 0.78. So 78% will be taken as the threaded area. So A and B is nothing but the area of the area for threaded portion. It comes to be 0.78 times the shank area. That is the complete area. The 0.78 times the complete area, that is 201.06 mm square. So it comes to be 156. That means the area for this third portion is less as compared to the complete area, the total area. Okay. So here there are two areas we have taken, the shank area and the threaded area. Okay, because this value is to be taken for the in order to find out the shear strength as well as the bearing strength of the bolts. How to find out the bolt value? The bolt value is nothing but the strength of bolt. Here, which things to be taken care? How to calculate the strength of M16 of grade of bolts? That means we have to find out the strength of bolt. So here, while finding out the strength of bolt, we have to first find out the bolt value, and bolt value is the least of the two values. Okay. So here there is a small figure. It has been drawn. These are the two plates. First plate is this plate. Second plate is this plate. These two plates are jointed in butt joints are there, and it has been covered with two cover plates, top cover plate and bottom cover plates, and it has been joined with two bolts. Okay, these are the two bolts. Okay, these two 12 mm two plates, it has been joined with the two cover plates. What is the thickness of the cover plate? So here thickness of cover plate, it has been taken as 10 mm. So 10 mm is the thickness of the cover plate. That means this top cover plate and bottom cover plate, it is having a thickness of 10 mm. Okay, it is having a thickness of 10 mm. Okay, whereas this two plates, it is having the thickness of 12 mm. So thickness of cover plates, main plate is nothing but 12 mm. Thickness of cover plates, top and bottom, it has been taken as 10 mm. So total thickness of the cover plate, it has been taken as 10 plus 10, that is 12 mm, 20 mm. What is the minimum thickness of the total thickness, minimum thickness of the plates? So that means 10 plus 10 is 20. So minimum thickness is in this case is nothing but the minimum thickness in this case is nothing but the 12 mm. ठीक है, तो 20 mm is the maximum thickness by adding these two plates. 10 plus 10 is 20, whereas 12 mm is the minimum thickness. ठीक है, here we will take the T as the minimum of the two plates. So here thickness is 12 mm instead of 20 mm. We are taking as 12 mm because it is minimum thickness. Why we are taking this as double share? Already in previous lectures I have shown you that we have to take a single share as well as double share. Okay, so in double share we have to take why double share, because it has been two share plates are there. That means these two plates, one plate is this 12 mm plates, and top plate is 10 mm, bottom plate is again 10 mm. That means there are two plates are there. So there will be share, there are two share planes in case of these bolts. So here there is a double share failures. Okay? So that means we are taking the value of double share failure as 2. Here we have taken taking this n as 2. So in this formula, that is in page number that is 75. Yes. So in this formula, that is V N S B FU upon square root of 3 NN A and B NS ASB. So here outside the bracket we have to multiply it with the shear planes. So how many shear planes are there? Here there are two shear planes are there. Why? Because it is having two cover plates. Okay. So here we have taken this as NS2. Yes. Okay. So here VDSB, that is n as 2 we are taken FU square root of 3 and gamma MB, the same formula is used. What about this NN A and B? Why we have taken NN A and B? Here we have taken this NN A and B, whereas this NS ASB we have taken as 0. Why? In this formula we NS ASB we have taken as 0. Why? Because we are considering this as no shank areas. Okay. All the portion we are taking this as that means this ASB, that is nothing but the shank areas. So we are not considering the bolts in the shank areas. We are considering the bolts in the threaded areas. So threaded areas only we are considering. That means this thing we are considering, and this we are Shank area we are considering as 0. So this 2 multiplied with this only this bracket, okay, fu divided by 3, and then a and b. No need to write down this thing that is ns as b. Why we are not considering the Shank area. Only we are considering the threaded area. So here we have taken as this 2 FUO divided by square root of 3 gamma MB. From the table we have taken as 1.25 from the table, and number of shear planes we have taken as 1. And what about the area of the threaded area? That is 156.889. It comes to be 57.95 kilonewtons. So here this is nothing but the first we have calculated this is V, that is capital V NSV, that is nothing but the shear area, shear strength of the bolts. Next we have to find out the bearing strength also, shear strength, and next is V, that is DPB, that is the bearing strength of bolt. So what is the formula for the bearing strength of bolt? So again it has been given in the IS code. So V, this is nothing but the bearing strength of the bolt, VDPB, that is VNPB, bearing capacity of bolt, divided by gamma MB. What is VNPB? That is 2.5 kb DTFU. What is D? D is the diameter of bolt. T is nothing but minimum thickness of bolt. Minimum thickness of bolt. Fu is the yield stress. Fb is the smaller of these values. What is this? E stands for the edge distance. 3 diameter of hole. Pitch value 3 times diameter of hole for minus 0.25. Fub upon Fu and 1. Out of these 4 values, that is 1, 2, 3, and 4. Out of this 4 values, the minimum value will be the kb value. The smaller value of the minimum value will be the kb value. So here I have written this formula here. So this formula is nothing but for the shears, that is the bearing strength of bolt. So VDPB, that is equals to 2.5 times KB D T FU upon gamma MB. So how to find out this FB? So KB is nothing but the minimum of 4 values. The minimum of 4 values. So 4 values is nothing but edge distance. E minimum is 1.7 times the diameter of bolt. So what is the diameter of hole? It comes to be 1.7, 1.7 into 16 is the diameter of bolt. Here 16 is nothing but the diameter of bolt. What is the diameter of hole? So the diameter of hole, factor of safety, we have taken as 2. So it comes to be 18. So this comes to be 18. So we have to take this value as 18. Okay. So we have to take this value as 18. So 18, 1.7 into 18, it comes to be 30.6. So we have taken as 40 approximately. Pitch value 2.5 times the diameter of bolt, diameter of hole, again same diameter of bolt. So 2.5 times the diameter of bolt is 16. So it comes to be 40. We are taking this as approximately as 50. Okay. So here we have taken as minimum edge distance as 40 mm and pitch distance as 50 mm. What is edge distance and pitch distance? Already we have discussed in previous lectures how to find out this edge distance and pitch distance. So already it has been discussed in previous lectures. So this it comes to be E minimum, it comes to be 40 mm, that is the edge distance, and pitch distance is, it comes to be the 50 mm. Again we have to use these values. So what is the formula for this? Kb is the minimum of the 4 values. So one value is first value is E minimum 3d0, second value is pitch 3d0 and minus 2.5, and fourth value is fub upon fu, and fifth value is 1. Out of this 4 value we have to take the minimum value. So E minimum we have taken as this 40 already, after calculations. 3 times d0, 3 times d0 is the diameter of bolt. So already we have calculated here. I have calculated diameter of bolt as 16. 16 multiplied 16 plus 2. Sorry, 16 plus 2. It comes to be 18. 16 plus 2. It comes to be 18. So here we have taken as 3 into 18. That is 40 divided by 3 into 18. It comes to be 0.78. Again pitch distance we have taken this as 50. 50 divided by 3 into 18. Again minus 2.5. It comes to be 0.67. It comes to be 0.67. Yes, 0.67. And FUB, that is 400 divided by 410. These two values depends upon the grade of bolt, that is 4.6. It has been mentioned in IS code 4.6. So it comes to be from steel table, from IS 800 2007. These two values we have taken from grade 4.6. These two values we have taken from table and from grade 4.6. Okay. So these are taken from the grade 4.6. Okay. So grade 4.6 it has been given. So from this grade 4.6, by referring the code, we have taken these two values. So it comes to be 0.97, and fourth value is 1. So that means the minimum value is 0.74, 0.67, 0.97, and 1. The minimum of these three values, first, second, and third, and fourth, the minimum values is, that is 0.67. So we have taken this as 0.67, kVA value as 0.67. So what is the formula for, that is nothing but bearing strength of bolt? So VDPB, that is 2.5 times kb. Kb is minimum value. What is this? 16. 16 is the thickness of, that is the diameter of bolt. Here we have taken this as 12, the minimum thickness. Here T minimum we have to take. Okay. One thing it has to be kept in mind. So here thickness, we have to take as T minimum. Here it has been taken as T minimum. So T minimum we have taken as this 12. This is 12. Okay. So T minimum we have taken as this 12. So 12 into 40, it comes to be, multiplied by 1 divided by 1.25. That is the gamma. That is the partial safety factor of bolt. So it comes to be 105. Okay. So the previous shear value was 57, and the shear strength of bolt, that is bearing strength of bolt, it comes to be 105. The minimum of these two values is nothing but the bolt value is 57.25. Okay. The minimum value is 57.97 kilonewtons. Next problem is, again we have to find out, we have to calculate the strength of bolts. Calculate the strength of 20 mm diameters bolts of grade 4.8. Here again the grade of steel, here in previous was 4.6, here it is 4.8. So here it is 4.8. For the following cases, the main plate to be joints are 14 mm. In previous it was 12 mm. Here it is 14 mm thick. Next is lap joint. First we have to take the lap joint. Next lap joint we have to have the shear planes as one. Okay. Lap joint we have to take the shear plane as one. Single cover butt joint with thickness of cover plate as 10 mm. That means there is single cover butt joint is there where the thickness of the cover plate is 1. Again this shear plane we have taken as n is equals to 1. Double cover we have to take n is equals to 2, where the thickness of cover plate it has been taken as 8 mm. Okay. Here the thickness it has been taken as 8 mm. That means there is a lap joint is there. What is lap joint? So this is nothing but lap joint. These are the one plate is there, another plate is there, and it has been jointed with the help of bolt. This is lap joint. Okay, first case is lap joint. What about second case? Second case is butt joint with single cover. So here I'm drawing the, here, yes, butt joint is there, and this is single cover plate. Okay, and third case is there, butt joint is also there, but it has been jointed with two cover plates. That means top one cover plate is also there, and bottom cover plate is also there. Okay, so these are the two cover plates. So first case, second case, and third case. First case is lap joint. Second case is butt joint with single cover, butt joint with double cover. So first in for first case, the shear plane it has been taken as one. For second single cover, again it has been taken as one shear plane, but for double cover, already we have shown in previous problem, so it has shear plane that has been taken as two. That means we have the multiplication factor for the formula. It has, we will take this as two. This problem it is to be find out. Okay, the strength of, that is strength of joint is nothing but the design strength of joint, minimum of three values. The again we have to take these three values. Okay. Again, how to find out the in tensile strength of bolt, that is TDB. We have to take this minimum. Again, this third formula is minimum of this. It has been mentioned in the IS code. The minimum third value. The first value was shearing strength of bolt. Next was bearing strength of bolt. The third was tensile strength of bolt, which has been tension capacity, which has been mentioned in page number 76 of IS 800 2007. What is the formula for the tensile strength of bolt? 0.7 FUB AN, that is should be less than F, that is YB ASB gamma MB divided by gamma M0. Okay, so this is nothing but the tensile strength of bolt. So with the help of this value, we have to find out the tensile strength of bolt. Here this it has been taken. Okay. How to find out this AN? AN is nothing but net effective area. Or how to find out the net effective area? It has been again mentioned as it in 2007. So net effective area, we have to find out pitch minus ND0, that is the diameter of hole, multiplied by thickness. How to find out the gross area? Area gross. So area gross is nothing but the gross area of the plate. That is meant nothing but the pitch value into thickness. Pitch value into thickness. So these are the formulas in order to find out the net effective area of the plate. Formula is P minus ND0 into T, and gross area of the plate P into T, solid plate. Well, how to find out the efficiency of joint? So efficiency of joint is nothing but the strength of joint divided by strength of full plate multiplied by 100. How to find out the efficiency of joint? That is strength of joint divided by strength of full plate multiplied by 100. Strength of full plate, how to find out strength of full plate? That is load taken of full plate Fu multiplied by, that is area of solid plate divided by gamma m1. Area of solid plate divided by gamma m1. How to find out area of solid plate? P into T. P into T. So here these are the problems, some of the problems related with this design efficiency. So here extra we are finding out the efficiency also. Okay. In previous problem we have calculated only the strength. Here in this problem we are calculating the instead of strength, we are calculating the efficiency also. Okay. So determine the strength and efficiency, both, that is nothing but the strength and efficiency, and determine the strength and efficiency of a lap joint as shown in figure. The bolts are 16 mm diameters of grade 4.6. The two plates to be jointed are 12 mm and 10 mm thick. Use Fe as 410 and grade of steel. If Fe is given as 410, directly we have to take as value as 410. If it is not mentioned directly, we have to take the Fe value as 410. Okay, 410 we will directly use the value of Fe as 410 also. So determine the strength and efficiency of a lap joint as shown in figure. The bolts are 16 mm diameter of bolts and grade of bolt is 4.6. The two plates are to be jointed in 12 and 10 mm. Use this. So here these are the two plates. First plate is this plate is 10 mm. This plate is 10 mm. This plate is 10 mm and this plate is 12 mm. So this plate is 12 mm. So these two plates are jointed with the help of the bolts. Okay. So this plate, it has been jointed with the help of the bolts. These are the bolts. So single bolted lap joint and double bolted lap joint. Okay. So we have to find out the efficiency of bolt to determine the strength and efficiency of lap joint in these two cases, in which the bolts are 16 mm diameter. Diameter of bolt of this is nothing but 16 mm bolt is there. So 16 mm bolt is there. And what is the grade of bolt? Grade of bolt, it has been taken as 4.6. Okay. What are the sizes of plates? 10 mm and 12 mm. What is the yield strength of bolt? That is 410 and grade of steel. Okay. So single bolted lap joint. So here it has been single bolted. So here shear plane is also one, and there is no as such shank area. So NS is 0, NN is 1, NS is 0, NN is 1. Shank area, we are not considering the shank area, we are considering the threaded area. So therefore NN is 1, NS is there is 0. But here double, that is bolted lap joints. So here there is a double bolted lap joints. So here there is single bolted lap joint, and here it is double bolted lap joint. So diameter of bolt is 16 mm. What is the diameter of hole? Extra we have taken as this 16 plus 2. It comes to be 18. So we have taken this as 16. It has been added with 2. Why we are adding with 2? The extra area, that is extra surface required for the that is nothing but the bolted area. Okay, where we are tightening the bolts. So diameter of bolt and diameter of hole extra we have taken as this 16.2 from the table. From this 2 we have taken from the table. What is area of shank areas? That is pi by 4. That is nothing but d square. The pi by 4 16 square. It comes to be 201.6. What is next area of shank area and threaded area? Threaded area is 0.78, that is 78%. Okay, it comes to be 78%. So 0.78, that is 78%. So 78% of 78% of the Shank area. So it comes to be 78% of Shank area. So 0.78 ASB, it comes to be 156. The grade of steel 4.6, from the grade of steel 4.6. What is the value of FUB? It is taken as 400 Newton per mm square. FU, it is directly given in question as 410 Newton per mm. FYB, it is taken as again from the table of grade 4.6. It comes to be 240. These things we have discussed in previous lectures, how to use the tables from IS 800 2007. So every time I cannot show the table from IS 800 2007. You have to refer the IS 800 2007 for yield stress and tensile yield stress of bolts and plates. Strength of joint is the minimum of three values. That is the design strength of bolt in shear, design strength of the bolt in bearing, and tension. Stick at these three values. So this formula, it has been taken from this directly. It has been taken from IS 800 2007 from page number 75. The FU divided by square root of 3 and gamma MB, NN A and B, NS ASB. Here in this case, if, here we are considering this value as 0. Okay, so here we are considering no shank areas, only threaded areas we are considering, and we are considering as single shear. Therefore, we have multiplied it with alpha of 1. So minimum we are multiplying this with alpha of 1. Why? Because single shear. Okay. So design strength of bearing, so again for bearing formula, again it has been given in as that is 75 page numbers. So 2.5 kb dt fu. Fu, it has been mentioned in the question, that is 410. Gamma mb, again it has been mentioned in table. N shear planes, again this value we have taken as 1. Why we have taken as 1? Because single shear it has been taken. In butt joint double cover, we have to take as double shear, but in that is lap joint or single cover, we have to take as the value as n as 1. Okay. So here kb, again the smaller of these values, so that is nothing but the h3d0. Already we have discussed in previous that is problem. The minimum of these four value, it comes to be there is 0.67 is the minimum value. Directly we have taken the 0.67. This 16 is the diameter of bolt. 10 is the minimum thickness. What are the two thicknesses given? So the out of this two thickness, the minimum thickness of plate we have to take. This 10 is nothing but the T minimum. So this is nothing but the T minimum. We have to take this as T minimum. And why we are multiplying with 10 to the power minus 3? Here we are converting this into kilonewton. So it comes to be 87.906 kilonewton. Again, third important thing, we are calculating as the tensile strength. Here we are calculating as the tensile strength. So this extra thing we are calculating as the tensile strength. Okay. So here we are calculating extra as the tensile strength. So design tensile strength for pitch. So what is the formula, again mentioned in 76 page number IS 800 2007. So TDB, it has been given as zero point 0.9 AN, that is FU divided by gamma MB, or it should be less than FI ASB gamma M0. AN and ASB we have already calculated here. Gamma MB and gamma M0, again we have to take this from the tables. And that is a table mentioned in IS 800 2007. How to find out the net area? That is nothing but the pitch minus n, that is the number of shear planes, d0, the diameter of hole, multiplied by t minimum, that is the thickness. So 50 minus 1 is the shear plane, 18 multiplied by 10, it comes to be area, net area as 320 square. What about the gross area? P into T, that is pitch value into thickness of the plate. The pitch value is 50, 50 we have taken. And what about this 10? 10 is nothing but the thickness. So it comes to be 500. So gross area is 500 and net area is 320. So here we are putting the values. zero point 0.9 AN is 320. FU is given in question 410. Gamma MB, it has been given in 800 2007, that is in table 1.25. Why we have taken is 10 to the power minus 3. Here we are converting this into kilonewton. Again fy here we have taken as this 400 ASB, again it has been given in question, and gamma m0 1.25. So it comes to be 109. So what is the, it should be less than this 109. So this value is or 109, it should be greater. So here the value it comes to be 94, which is less than this 109. That means it is correct. So here the tensile strength of bolt, here the value of tensile strength of bolt is 94. Okay. So here the design strength of joint, here the minimum value of the three is nothing but the design strength of joint is 28.97. The minimum of three, that is shear, bearing and tension. So out of this three, shear, bearing and tension, the minimum is 28.97. So here we have taken as design strength of joint as 28.97. How to find out the strength of, that is the full plate? P, that is strength of our load taken by the full plate, or strength of full plate. So Fu multiplied by area of full divided by gamma m1. So Fu is nothing but 410. Area full we have taken as 500. Gamma m1 it is 1.25, and Y we have taken as 10 to the power minus 3 kilonewton. So it comes to be that is load taken, that is by the full plate, it comes to be 164 kilonewtons. How to find out the efficiency? Efficiency is the that is the strength of bolt divided by, that is nothing but the strength of full plate. Strength of bolt divided by strength of full plate. What is strength of bolt or strength of joint? So it is minimum of three values, that is 28.97. What is the value of this strength of full plate? It has been calculated as 113.64. So we have taken as this 113.64 multiplied by 100. Why? Because we are converting this into percentage, so it comes to be 25.49. So in this way, we can also find out the efficiency of plate. That is the efficiency of plates. How to find out the efficiency of plate? So that is the strength of joint divided by strength of full plate, full joint. So how to find out strength of full joint? The strength of full joint or full plate is nothing but Fu area gross divided by gamma and 0. It comes to be 113.64. So here we have taken as 113.64. It comes to be 25.49. Again, case two, that is a double cover. That is the nothing but the double bolt lap joint. First case was single bolt, and second case was double bolt. The double bolt lap joint. The design strength of bolt in shears, again the same thing we have to calculate, but here in this case, and we have to take for double bolt. Okay, here and we have to take for the double bolt. So here we are taking n as 2 for double bolt. So here we are taking n as 2 for double bolt, and previous problem we have taken this as 1. So here we have taken as 2. Same procedure is there. Only we have taken this n as 2. Why? Because it is double bolt. Here we are taking this n as 2. Why? Because it is double bolt. Here we have taken this n as 2. Why? Because it is double bolt. So same procedure is there, and we are taking this for double bolts. Okay. So these three things to be calculated in order to find out the strength of bolt. First is the shear strength of bolt. Next is number two was bearing strength of bolt, and number three is tensile strength of bolt. Out of these three values, the minimum value is the strength of bolt. The minimum value is nothing but the strength of bolt. Okay. The minimum of three, it comes to be 41.33 kilonewtons. Here again we have to find out the strength of solid plate divided by strength of the full plate. Strength of solid plate, it is 250 multiplied by that is 500 divided by 1.10. 1.10, it comes to be 113.64. That is the formula for the solid plate or full plate. It is Fu multiplied by area net, that is area of full plate divided by gamma and 0. It comes to be 113. Efficiency is the minimum value of this divided by the that is the solid plate, area of the solid plate or the strength of the solid plate. So it comes to be 36.37. It comes to be 36.37. So in this way, we can also find out the efficiency of bolt, and also we can find out the strength of bolts. Okay? So in today's lectures, we have calculated the strength of bolt as well as the strength or efficiency also. So here important concept, we have calculated the efficiency. Well, how to find out the efficiency? Efficiency is nothing but the strength of plate or strength of bolt divided by the strength of solid plate. Strength of solid plate. So in these divisions multiplied by 100, so with the help of this we can find out the efficiency of the plates, efficiency of the plates. Okay. So in this way we have, in today's lectures we have calculated the efficiency of the plates. Okay. So here we will end this today's lectures. Again, we will have some more lectures on the steel structures. So you have to go through all the lectures because everything it has been mentioned in IS 800 2007. So we have to take the tables also. We have to take the various datas which has been mentioned in tables also. Okay? So all these things to be taken care while calculating the strength of bolt or efficiency of bolt or tensile strength of bolts. So these things to be calculated from IS 800 2007 from page number 75. We have to take these all things from the page number 75. Okay. So here we will end this today's lectures. Thank you. Thank you everyone.